This is Intro to Proofs, section 3.3. We're doing progress check 316. So in this progress check, in proofs by contradiction, it's really important that you can negate things well. So they're kind of reviewing how to negate things. It comes in handy a lot with the rational number stuff, because when something's a rational number, then that tells you something about what it looks like. But if it's irrational, that tells you it just doesn't look nice. So that's all you know. And so it's always easier to kind of negate statements with irrational numbers. So you can say things about rational numbers. So for instance here, number one, for each real number x, if x is irrational, then the cube root of x is irrational. So we're going to negate this. That means to negate it means for each, that means that it's a for all. So we write it there. So I'm going to write it, we'll write it in English. So we'll say there exists a real number x such that, I'm going to negate this. Negating an if-then is really becomes an and statement, okay? Because if if-then is false, that means that the if is false, the if is true, and the then is false. So x is irrational, and the cube root of x is rational. X is irrational, and cube root of x is rational. Okay, statement number two. For each real number x, this thing is irrational or that thing is irrational. All right, so then negating it, so instead of for each, there exists a real number x such that here I've got an or, so that means it used De Morgan's law, such that x plus square root of 2 is rational. So the or turns into an and x minus square root of 2 is irrational. No. Negative x plus square root of 2 is irrational. I'm negating. Negation of irrational is rational. Okay, number three. Number three says for all integers a and b, if 5 divides ab, then 5 divides a, or 5 divides b. Okay. So to negate that one, say there exist integers a and b. So the for all applies to a and b, so now there exists applies to a and b. There exists integers a and b such that, now I'm negating an if-then. So if 5 divides ab, then an or statement. So to negate an if-then, you must have the hypothesis is true, but the conclusion is false. So such that 5 divides ab such that 5 divides ab, but is really another way of saying and. It's just like surprising and. But now I have to negate a or statement, so it turns into an and. but 5 did not divide A and 5 does not divide B. Does not divide A and 5 does not divide B. All right, let's see. All right, so then our last one there is for all real numbers A and B, if A is greater than 0 and B is greater than 0, then this certain fraction equation is true. So negating that, there exist numbers A and B. There exist real numbers A and B. A and B. And there exist real numbers A and B. And then negating an if then means such that A is greater than 0 and B is greater than 0. That A is greater than 0 and B is greater than 0. So negating an if then, the hypothesis is true, but the conclusion is false. But 2 over A plus 2 over B equals 4 over A plus B. Okay, that concludes that progress check. Some extra practice negating sentences.